This video is for lesson 16-4, proving a quadrilateral is a square. Learning goal is to develop criteria for showing that a quadrilateral is a square and then use those criteria. So let's first think about what a square is. A square is a parallelogram. It has four 90-degree angles and four congruent sides. A square is a rectangle and it's a rhombus. So in previous lessons, we've discussed ways to determine if a shape is a rectangle and ways to determine whether a shape is a rhombus. If we use those same theorems, we could tell if a shape is a square. Number 2 is an example problem. Given parallelogram DAVE with these coordinates, show that it's a square. So let's first graph this so that visually we can see whether it looks like a square to us. And then we can even use our theorems for better justification. So -1, 1 is right there, and that's point D. 0, 7 is 1, 2, 3, 4, 5, 6, 7. Right there, that is point A. 6, 6, 1, 2, 3, 4, 5, 6 to the right, and 6 up. Right there, that's V. And then 5, 0, 1, 2, 3, 4, 5 to the right, right there. That is point E. Okay, let's connect these together. Question is this a square? To be a square, we need to have four congruent sides and four right angles. We can determine whether the sides are the same length by using the distance formula and finding the distance of these segments. And we can determine if the angles are 90-degree angles by using slopes to tell whether the joining sides are perpendicular to each other. For example, if we wanted to find length AV, we would use the distance formula. The horizontal distance across here is 6 units. The vertical distance between A and V is just 1 unit. And this is the square root of 37. Do the same thing on all the other sides to see if you get the square root of 37. And if you do, then the sides are equal. To determine if the angles are 90 degrees, let's find slopes. So the slope of AV can be found with the slope formula. The vertical change from A to V is that it goes down 1 unit. The horizontal change from A across to V is that you go over 6 units, -1/6. Then find the slope of one of the sides that joins that, like EV. The vertical change from E all the way up to V is 6 units. And horizontally, it is just 1 unit to the right, 6/1. Notice that these numbers are negative reciprocals. That meant that the segments were perpendicular. We could do this with all other angles as well to see if they're perpendicular. Question 3. Several students in class make some statements. Decide whether you agree or disagree, and if you disagree, change the statement to make it correct. Let's do number A together. A quadrilateral with congruent diagonals must be a rectangle. Yes, let's agree with that one. Think about different quadrilaterals. For example, one of them that we talked about was a kite. A kite does not have congruent diagonals. It is shorter across here than it is up and down. Another quadrilateral we thought about was a parallelogram. And some parallelograms are not rectangles. For instance, this one here. This is a parallelogram, but it's not a rectangle. Again, the diagonals on this are not the same length. It is longer that way than it is that way. If a quadrilateral does have congruent diagonals, it must be a rectangle. Let's do question B together as well. A parallelogram with two right angles must be a square. I think this time we need to disagree with this statement. Let's consider some examples. A parallelogram with two right angles could look like this. Here's a right angle, and here's a right angle, but if it's longer than it is tall, then it's not a square. This is a rectangle that's not a square. So to correct the sentence, we could say a parallelogram with two right angles must be we could change this word to rectangle, and then it would be a true statement. Please try question C on your own. This one here, we need to say no, that we disagree with this. If we have a four-sided shape and there's one pair of opposite parallel sides, the shape could look like this, where the top is parallel to the bottom. But if the sides are not parallel to each other, then it is not a parallelogram. So to correct this sentence, we could say a quadrilateral with two pairs of opposite sides is always a parallelogram. Or another way to correct the sentence, a quadrilateral with one pair of opposite parallel sides is always a trapezoid. That would be another way to fix the sentence. Please try question D. I'll pause the video for you. This one is yes. We have to agree with this. A rhombus has four equal sides. And if that rhombus also has four equal angles, then yes, it must be a square. It must look like this shape. That's the only way to have this. With four equal sides and four equal angles, they must be 90-degree corners. That is a square. Here's a check your understanding question, so I'll pause the video for you to work on this. Elena has a garden with congruent sides as shown. Describe two different ways to show that the garden is a square. Recall that a square is a rectangle and a rhombus. We're told that there are congruent sides, so we're told that this is a rhombus. If we can come up with a way to show that it's also a rectangle, then we would know for sure that it is a square. So we have several theorems we can use to tell if a shape is a rectangle. Just pick any two of them. For example, we could check if one of the angles is 90 degrees. We had a theorem the other day that says if one of the angles is 90 degrees, then we would know that the shape is a rectangle. Another way to tell if a parallelogram is a rectangle is to check the diagonals. Let's check if they're congruent. If it is the same length from corner to corner, then we would know that the shape is a rectangle. So in this lesson, we looked at the shape called a square and considered ways to tell if a four-sided shape is a square.